Hello and welcome to the Middle School Math Summit. I'm your host, Kathy Martin, and I am so excited to bring you our interview with the one and only Becky Lord. Becky, thank you so much for being part of this event. I am so excited to chat and talk all about effective word problem instruction with you. I know this is a topic that so many teachers struggle with, so I'm excited to dive in. But before I share all of my burning questions for you, I would love for you to introduce yourself and tell us a little bit about your background as an educator.
Absolutely. Well, first of all, thank you so much for having me. I love to be able to share. It's like every time you find something that's effective and helps students, I want to get the word out. It's like, everybody, look, this will work better. So every opportunity to share is greatly appreciated. So I work fully as a consultant doing training for schools and teachers. But I started as a middle school math and special education teacher. So when I got licensed as my master's to be a teacher, I got licensed in both middle school math and special education, and I ended up getting hired for a brand new position, which was to teach a small group math class to students who are all on IEPs and who were struggling enough in the regular classroom, they'd been pulled out into a small group classroom. So right from the start, I knew that whatever was happening in the regular classroom for instruction wasn't working effectively enough for these students. The school I was at had a language-based program, and so a lot of the students had dyslexia or language-based learning difficulties. Some of them had a lot of difficulty with understanding numbers or math, but some of them actually had very strong number sense and really were affected more by the language difficulties. And then I had other students from the school who were stronger in other areas, but were really struggling in math. So it was a mix of students. And so I taught that for sixth, seventh, and eighth grade for 6 years, and then switched into a little general ed math teaching at seventh and eighth grade. And then went on to do some coaching and co-teaching. And then after being in middle school for almost 9 years, I became a K-5 elementary math coach. And that was an opportunity to take, once we had found these more effective ways of teaching math, to be able to bring that to the K-5 level, where rather than teaching, oh, students are already behind, they already don't understand this or don't know these math facts, how can we teach them right when kids are initially learning it in a much more effective way so that students are coming to middle school, much more prepared? And so that was what I've really gotten into, especially as what are the most effective ways to teach math? And I often say, the thing that I was really fortunate about as being both a middle school math and a special ed teacher, the district I was in, I was able to go to a lot of training in both of those fields. They were very supportive of training. And so I was focusing on learning all, from a lot of really great middle school math people. And I also was working in tandem with people who were really trained in language-based and reading difficulties. There's much more knowledge and research about how to effectively teach literacy. And so I was always working in tandem with those the people trained well in that. And so then it was a process of how do we take that and apply it to math, and really find the most effective way to teach math to everybody.
That's awesome that you have such a wide range of experience, like special ed, general ed, K-8. I think that's going to make this conversation even better. Um, so are you ready for my first question? Because
I'm
I'm excited
ready.
to dive in.
Let's
Okay,
do this.
so I have lots and lots of questions, but before we dive into actual strategy, why do you think so many middle school students struggle with word problems? Like, what are some of the common misconceptions about teaching word problems?
I think one of the biggest challenge with word problems is that really by the time we're giving students a word problem, there are so many embedded skills in that word problem. Like there's so many components of what they really need to be able to do well. And now we're putting it all together into usually a more complex situation. And so students could be struggling for a whole bunch of different reasons. First of all, we want to think about the language that students are having to process in that word problem. In literacy, in structured literacy, there's really, the idea of having it be at the student's reading level and gradually increasing the complexity. But as students are learning that in math, I think often we just create a word problem. We don't really think that much about the students, reading level. This shows up at elementary. We give first graders word problems before they've even really learned how to read. But there is a progression. And so I think first of all, being aware of the complexity of the language and is it at a level that students are able to process. And have we specifically taught all the vocabulary and the language in it? Again, sometimes we give that and then it's just a lot for students to process if there's a lot of new words in there, a language they don't really understand. But then you get into things like, do they understand the models of, the mathematical models, which is the biggest component. I know we're going to talk about this more today. That really has been missing in word problem instruction. A lot of the focus is on just read the words, make sense of it, solve the problem. But we haven't taught the mathematical models that are consistent. And so students then need to learn the model so that they can understand the situation that's happening mathematically, and choose the right situation. As they are able to create a visual model, this helps them then to understand what's happening, what the operations might be to solve it. And so then students also need to know how to actually do the calculations, right? And so we have students who don't yet know math facts well, or don't yet know how to do a multi-digit operation, or fractions and decimals and negatives and all the different things that start to come up. So you can start to see when you look at a word problem, there's so many areas where students need to have very secure skills. So ideally, when we're teaching, we would start with the basics, teach each thing, and then gradually increase the complexity, gradually start to integrate more than one skill together. Often I see people, there might be a lesson where you're doing something then basic, or you're teaching a student how to solve a particular type of problem, but then the word problem might be like a multi-step complex, language, and there's just this big leap from there that students really aren't ready for yet.
Yeah, I feel like I don't want to generalize, but I don't do a good enough job of like almost compartmentalizing each step, each skill, right?
Yeah.
Before we throw the kitchen sink. So okay, how can teachers help students move from the keyword strategy that I feel like we've been taught as students and we've been taught to teach as teachers? Like, okay, look for this word, keywords like sum, all together, things like that, and then you do that, like all together means adding.
Right.
How do we move away from that so that students truly understand the actual content? I mean, I understand they have to understand the language, right? Like what is being asked. But what are some actual strategies that we can use that's not just keyword based?
Mm-hmm. Absolutely. Well, first of all, this is where it's helpful to realize that there is research around what's effective in learning. And one of the most highly researched things has been effective word problem instruction when we look at math. I didn't know about this my entire middle school math career, and I was even already an elementary math coach. I did a class where I did a review of the research to see what was out there and came across this. So this is where I discovered what's called schema-based instruction, and what the research actually shows. And so, first of all, the research is pretty clear that teaching keywords is not effective. There is no research supporting that teaching keywords is effective, and also that the idea that a keyword means a particular operation is also not supported by research.
What
And yet,
doesn't
like,
feel effective? It doesn't feel effective.
right.
So,
And it feels like, right? Like, oh, this just feels like a little, I don't know, a hint, because if you think about real life, are we going to teach students to go out and expect that everyone's always going to make sure they put the right keyword in a
that's
real life situation? That's not how the world works, right? So there is just no research supporting that. And in fact, we know that they're really not effective. So that it's part of our challenge sometimes is getting that research into the classroom where we recognize that's not effective. And then what is effective? So there's two approaches that are highly supported by research. And one is to use what they call an attack strategy, or it's like a metacognitive strategy. And this is really just learning a sequence of steps to use with problem solving. So these are often those acronyms you may have heard of. Like, three reads is a good start for that. You can do like, it might be read, understand the problem, solve, model, draw, like you get these different steps. So I'll share some examples of what I like to do for that. So that is supported by research to have a consistent guidance for students on the sequence to go through to help them make sense of a problem and then move sequentially through how to solve it. So that's what we call attack strategy, how students attack a problem is, where that word comes from. And the other thing is schema or schema-based instruction. And a schema is just a mental structure that helps us understand and organize information. And so there are schema for addition, subtraction story problems, and for multiplication, division, and for more advanced operations as well, but especially focusing on those. And again, that's something that most teachers aren't aware of. And they're actually in the Common Core standards, but again, we talk about the type, but we don't necessarily teach them explicitly or really show students how to model them. So those two approaches are definitely what's the most supported, as well as, like you said, I think it's always important that while we don't want to teach keywords, we do want to teach vocabulary and language. It is important that students really understand the vocabulary, can process all the language. We're just not going to teach them that look for a particular word because this is going to tell you what operation to do. One
Right.
example, if I said Mary had 5 apples, she has two more than Joe. How many does Joe have? Right? If you learn that more than means add, you're going to see 5 + 2 is 7, right?
Yes, right.
But I just said Mary has more than Joe. So you actually have to subtract the two. So what we need to do is make sense of that and model who has more, who has less, rather than thinking that that keyword is going to mean you just can add and you're all set.
Yeah, yeah. Okay, can you take us through um like the schemas that you were just talking about? Like what does this actually look like? What does this mean? Like what is a schema?
Yeah.
Because I know that I will say that schemas, I was just introduced to schemas like not too long ago.
Yep.
And so I know I am definitely not alone here. We probably have teachers, watching, being like, what are you even talking about? So,
Absolutely. And, if anyone's in that place, I was in that place for a long time. Like I said, I didn't discover this till much later. But schema are these organized structures. So if we think about additive reasoning, so story problems that would be considered addition or subtraction, there's different types you can think of. Sometimes you might hear of put together, take apart, difference or comparing, add to, and take from. This is the language that the Common Core standards use, and people may have heard of in math. But I like this model of simplifying it a little bit more to just these 3 types, which is combine, compare, and change. So really all problems with addition and subtraction would fall within this. And we're working with elementary students, these could be very simple numbers. But as students get older, these can be fractions, decimals, integers, variables, and so the types are generalizable to whatever the method is that you're working with. So if I talk about what is a combined story, and I'm just going to use some in elementary, we're often saying things like number stories or stories problems rather than word problems. It's a little bit, more fun sounding. But so combined is the idea of like a part whole. So I could say there's 3 black dogs and 2 brown dogs. How many dogs are there all together? So we have our parts are the 3 black dogs, the 2 brown dogs, all together there's 5. I also could say there's 3 black dogs, 5 dogs all together. How many dogs are not black? So it's the same model. It's just what is the missing piece? The missing piece could be a part or it could be the whole.
uh,
Okay. And in
yeah.
that sense, also, I'm not going to teach them that this is an addition or subtraction story. Like in that second situation, let's say we had D as our variable for that unknown number of dogs. It could be 3 plus D equals 5, or 5 minus 3 equals
Mm,
D.
uh-huh.
And so there's more than one way to write that equation to
Mm-hmm.
solve for it. So I don't want students to think this is only an addition, or only a subtraction story. You really could write it either way. And so I like to use, so this template, which I'll talk about a little bit more, builds in an attack strategy along with the schema. So it's basically like a graphic organizer that students could use. I have teachers, they put it in a sheet protector. And then anytime they do story problems, they just, they pull this out. I have one for multiplication division that I'll show next also. And it gives students, again, a consistent structure for solving story problems. Because again, what we want them to do is like every time I approach a story problem, I'm going to go through these steps. That's how things get internalized. When there's no structure or the structure is different every time, it's difficult for many students to internalize how to consistently attack and solve a word problem. So the
Okay, so based on just what I'm seeing on your template here,
Mhm.
as you assign the word problem, do the students have to decide whether it's a combine, compare, or change type of question? Or
Yes.
okay, so
Yes,
you're kind of teaching them the
exactly.
differences.
And the first time you would probably just do one type, like maybe just the
Mhm.
combine or just the
Right.
change. I do recommend right from the start having the unknown sometimes be the part and the unknown sometimes be the whole, because if you don't, then students will get in the habit of like, oh, I always just add the numbers
Yeah.
and it gives me the
Yep.
total.
Yep.
So I want them to have to think through, oh, is this the part or the whole? And then model it so they have to make sense how to solve it. In that example, so these are Cuisinart rods. I don't know, if people have seen these before. You can get them in a little bag. I have a whole bin of them over here. But just an example of how to solve that. I said what we had three, plus two, right, equals five. So you can see if students are modeling like this, it's going to make basically what matches that there is the bar model. So I think of this as a concrete representation that's going to build into this bar model, which the bar model eventually works great with larger numbers as well, or variables or fractions. So, you only want to actually concrete model small, simple numbers so that it's not too complex. Um, because then I gave the second example of what if we had three black dogs, five dogs all together? How many dogs are not black? So now you've got this missing
Yeah. Uh-huh.
unknown, right? Which you could then fill in there the three and the five and use like a question mark or an X or a variable for the unknown. So even when I start with young students, we start with using some kind of a symbol for the unknown and then writing the equation with their unknown. So that becomes an innate thing. So variables aren't
Yes.
just a scary thing that comes up later. It's representing an unknown amount.
I love that. Yeah, getting them comfortable with variables.
Exactly, right? So there's really a lot of skills they're doing here. So that's the combine type. The compare is really when we're comparing size, which one is more, which one is less, greater than, less than, taller, shorter. So we have two different amounts that we're comparing. And then the unknown can be any one of those pieces. So it could be the smaller quantity, the larger quantity, or the difference could be the unknown. So it could be, if I use these same models, it could be that I have, let's say, three, let's do cats, right? Five, I didn't think of. I go with dogs. Maybe I should stick with that. Three black dogs, five dogs, how many more, if these are the brown dogs, how many more brown dogs are there than black dogs? And so you can compare them and find the difference. Okay. And then again, you can write that story as the equation as an addition or a subtraction. Or I could say that there's five black dogs, there's three less brown dogs. So how many brown dogs are there? So that's knowing the difference and solving for the smaller
Mm-hmm.
quantity. So I want students we would teach comparative language first and brainstorm some of what those words mean and how we know when we're comparing, and then making sense of each number that we said, what piece of the model is that. And then the last one is the change type. And this is when you have an amount and then something happens. So some kind of an action. Either you get more or you get less. So if we have, birds, they might fly away, or cookies might get eaten, or maybe someone, more birds flew over. In elementary, this is where these ideas are pretty simple. But you have in a starting amount, it changes, it either increases or decreases, and then you have an ending amount. And so it's more this sequential where you come up with a specific equation that represents what happened in the story. And what I like to do is for students is use this equation template of, the square, the rectangle for the number, the circle for the symbol, so that they get a template for always writing this, but it leaves it open to whether they're going to write addition or subtraction. It's not giving them how to write it.
Okay, yeah, that sounds great.
And then overall, so then,
I was wondering what the rectangles and circles meant in
yeah.
the, yeah,
Yeah, there's a lot on here. When I'm working with students at elementary, we do these things first before we're putting it all together. So they already have learned, to use that template to write in their
right.
equations. We've worked with the Cuisinart rods already and learned to model and write equations from them. So now we're starting to put it all together with context of the situation. And so the attack strategy I use here is read based on the three read strategy that many people have probably heard about, or you can Google it if not. But you read it first time, think about what is this problem about? Second, what is the question it's asking? And third, what is important? And I like the idea of first just reading, for context, big picture. What are we even talking about, right? And this, I'm talking about dogs and right. What's the question? Because I think we need to identify what the question is that we're trying to figure out before we know what information is relevant or important. So making sense of that and then helping us go back. Oh, so what information would we need to know? And then one other thing you can do with students is start with the story problem as being numberless. Like don't give students the numbers right from the start because many students, as soon as they have the numbers, are going to want to
They,
jump into solving.
yes, yes.
So if you would just have blanks where the numbers are going to be, that will help them make sense of the story using these questions and also think about now which type is it? So we'll read it and then we'll decide what
Um,
type it is based on the situation that's happening in the story before we find out what the numbers are and then look at filling them in.
if you don't have the Cuisinart rods, can do you just encourage teachers to have kids like draw draw something or, you know?
Yep. Yeah. And definitely at middle school level, especially if your students haven't used Cuisinart rods. I mean, they're a great tool, but if they haven't used them, there's definitely a learning curve to figuring them out. But when I was in middle school, we did a lot with the bar model. And so we really spent time teaching students how to draw a model. And so if students haven't seen these models yet, I think it's very worth teaching them how to model, because these can be a powerful tool for solving even more complex problems. But yes, you can teach them how to, model the part, and that together that's going to equal the whole, right? And that the compare, one is taller or shorter, right? And then we're trying to figure out
Yeah.
what the difference is between them.
Okay, cool. Anything else that we should know about the adding and subtracting?
I feel like that's probably a good take on the overall. So using this
Okay.
template, there's a little area they can model with the Cuisinart rods or draw a model, or, once students, if they're comfortable using the what's on the right here, then they don't necessarily need to draw a model, just fill it in. And then I have them write the equation. And I often do encourage them to write more than one equation because it's helpful for students to recognize, like we talked about, you could write an addition or a subtraction equation for that. It helps them with that flexibility.
Yes, I was
And
going to
then
say it teaches them that there's not always just one way.
yes, exactly. So they get used to thinking about what's another way I could write this. And then there's space at the bottom, to do their solving and write their final answer there. All right. And then multiplication and division. So, the attack strategy part is the same, but then we have these other types. So equal groups, where the unknown can be the number of groups, the group size, or the total. So this visual shows three groups. I have the dot, dot, dot to show it could be any, and so that's something to figure out with students say, well, this example shows three groups, but it could be more, it could be less. That's part of what we have to figure out. And then an area or array, a third grade when I teach it, I have those two separately, but then we combine them into a rectangular model. So it's basically rows and columns. Even area is like rows of squares.
Hmm.
3 rows of 5 squares gives you an area of 5. 3 times 5 is 15, but total area of 15 squares. And so they can fill that in. And then at fourth grade, we teach the comparison model as well for multiplication, which is, if I have 5 pencils and he has 3 times as many as me, how many does he have? And so you can use the bar model with that as well. And all of these, the Cuisinart rods work well for introducing them, but by the time we're at the middle school level, teachers might prefer to teach the model and then make it a little bit more, because drawing is a little more generalizable to what the different situations are.
Yeah. Okay. Yeah, no, that makes it very easy. Do you have a suggestion on where, like, if we were teaching multiplication and division with the word problems, which would be the best place to start in terms of the story? Like, should we start with equal groups? Should we start with area or compare?
Compare is definitely the most complex of them. I would start with equal groups. That's probably what we most commonly experience is equal groups. And then, it's interesting in elementary, there's a lot of use with arrays. I think they're not used as much typically once you get to middle school. So you might want to talk about an array. I define it as an arrangement of rows and columns. So when we are, go into a classroom, a traditional classroom with desks and rows, or an auditorium with seats and rows, that kind of gives an real life example of when you would see an array. And then area, a lot of the classrooms are in the floor is square tile, so it always works out really well to talk about, what is the area, and it's really rows of squares. And so I'd probably go through that equal groups, a little bit of array, and then building into the area, and then comparison model after that.
Okay, yeah, that's awesome.
And it works great. You can use this with, ratio and proportion. I think it builds up to that a little bit as well. And then so these are the templates, and then I have an example of a middle school. I'm just going to shift my so taking this as an example of I have this as a seventh grade problem, and I love one of the things I talked about was using consistent graphic organizers, and I love this structure. Probably many people have seen this, but I've heard it called link sheets, rule of four, different things. where you have a word problem, a table, a graph, an equation. And our goal is eventually we want students, if I give them one, I want them to be able to come up with the other three. So initially, you
Okay.
usually start with that word problem. But if you look at this word problem now, and this was one I'd made for students when I was a middle school teacher, one of the things I suggest also is that when you're doing something at first, keep the numbers simple because small numbers are much more intuitive to our brains. And so if you're working with small numbers, students can pretty intuitively understand that. And so there's this idea of cognitive load, which just means how much new information can your brain hold and process at one time. So if you're teaching a whole new thing, I don't want students' brains bogged down with difficult numbers. I want their brains to, the numbers to be easy so that they can be focused on whatever the new thing is I'm wanting them to learn. So when you're doing something initially, keep the numbers very small and intuitive and easy for students to work with. As they start to understand it and get stronger with it, then you can increase the complexity of the numbers for them. So this story, Miss Lord is shopping for pencils for her students next year. Packs of pencils cost $4, and she wants to have a pack for each student. She also wants to purchase a basket to store them in for $9. How much will it cost? So if we get to something like this, which is going to lead to us making, a table and a two-step equation, if you think about it, this is actually going to include the equal groups multiplication model and then combining with that $9, that constant there.
Hmm.
So it really becomes a two-step, a multi-step problem, but underneath it is the schema from the addition, subtraction, and the multiplication division types. So where it says bar model, I could have students actually model this. And I tend to think of these situations, so we might go through the three reads. What is this about? What is the question? What do we need to know, right? Even this question of how much will it cost? Well, that depends, right? How much it's going to cost, it depends on what? It's going to depend on how many we buy, right? And
Hmm.
so having that conversation with students of what's the known and the unknown, and also it's kind of like a what if situation. Well, what if I don't, I buy one? What if I buy four? What if I buy seven? And then doing that in the table where, you show the works, you have students see the consistent process they're doing every time to solve it, which will help them to develop that equation. But you can see how this is, I try to do this in a very scaffolded way where it's one bit at a time. And they can do the model that goes right along with this as well.
Yeah, I mean that's this is awesome. Like it's so visually appealing and makes it just I don't know. I feel like if I were to present this to students, you could work each section,
Hmm.
and yeah, I'm
Yeah.
sorry. I'm just reading it all. I'm like, oh yeah, like
Yeah.
okay, yeah.
You're taking it all in. Yeah.
Uh-huh.
Yeah, because even here in the table, we have to identify, well, what's our X, what's our Y? We're going to label them. We're going to show our work. We're going to come up the coordinate points so because often the tables you'll see for students in middle school curriculum don't have all these columns, so students don't necessarily see the connections. So I want them to see how this X and Y, we're going to put it together. That's going to give us what we're going to graph. Showing the work and looking, oh, what did we do? What's we do? Every time we took 4 times the number, right? Plus 9
Hmm.
and got it. That's going to lead to that bottom line where we write the equation. The equation
Yeah.
section, yes, we want them to write the equation, but I also want to think about what are all the understandings I want students to have. I wanted them to understand what the unit rate is and identify that. You could also ask them what is the constant, write the equation. But then this was seventh grade, and I wanted them to also see how they could use the equation to solve the equation for one of the unknowns. So once they write the equation, y equals, 4x plus 9, whatever it might be, well, now can we substitute 15 students in for the x and solve it? Can we substitute, well, if the cost is $77, let's substitute that in for the Y and then
Hmm.
solve for X. So we're really asking them to integrate a lot of different skills and continually
Hmm.
practice them, which really helps students put it together. And I would use this structure consistently for a lot of the problems we did. And so students got really familiar with the structure. And it's pretty easy, you could just take a problem you have in the curriculum, put it in the story
Hmm.
problem, just use it as a template, and it doesn't take that much work then to keep using it.
Yeah. And they don't even need to know what slope intercept form really is, because that's what
Right.
this is, right? Um,
Right,
Yeah.
because when you start, it's just how you're solving it. And they might do
Yeah.
nine plus whatever, but a lot of students, so it doesn't even matter what order they write it in initially,
Mhm.
right? And then later on, we can say, oh, so this is actually slope-intercept form as well, but you do it in a very intuitive way. And that's another recommendation, is the most basic level knowing. This comes from a lot of my training I did was with Mahesh Sharma here in Massachusetts. And he talks about the first level of knowing is intuitive. And that's just the level at which students have a natural innate understanding of something. And I always try to start there because if you start there, then for something in their real life, like I feel like most students would understand this situation, then you can build off of it. Then you can model it concretely. You can get into more complex things. But I think that, stories like this that are intuitive help students. And then you can start to say, oh, now I see why you write the equation like this because this
Right.
is the math. This is how you would just figure this problem out.
Right. Yeah, I love this. I love the separation, but the fact that it's like it all combines so nicely together.
Hmm. Yeah, awesome. Even the graph, we would talk about, once we fill this in. And I like to go a couple numbers in order and then jump up because I want them to switch to that thinking, well, what if it's 7? What if it was 18? I don't want them just adding on another $4 each time, right? We need to get them
Right,
to
right, right, right.
linear, left or right kind of thinking on this. So you could vary the numbers depending on what your students are ready for. And then for the graph, we would have to look at what are our X and Y values and what's going to fit, what should we use on the graph? Can we go up by ones? Should we go by twos, by fives? What is it? So they're starting to think about that. All those things are skills they need to develop and think through that sometimes we give them something that it's already done for them. So they never really make sense of that part of the math on their own.
Yeah. Wow. This was awesome, Becky. Is there anything else that you would like to share?
Yeah, I mean, I think those are some of the main ideas, and I could share all those resources with you. Yeah, are there any other particular questions that you have?
No, I'm excited to dive into our bonus section because we're going to be, or in our bonus interview, because we're going to be talking more about scaffolding. I want to ask you more about just like different digital tools, platforms, things that you like to use for more practice and instruction. And I know that everything that you just showed, you're going to be providing in our VIP toolkit. So if you have not upgraded your ticket, it is not too late to do that because you're going to want to grab everything that Becky just shared with us, which is incredible because then it means we just don't have to create our own. So it's going to be awesome. Becky, thank you so much. Where can we go to learn more about you online?
Absolutely. Well, thank you. My website is lordmath.com. So LORD math.com. So you can find a bunch of different resources there with some videos and different things. And then on social media, I'm at Becky Lord Math on Instagram and LinkedIn and Facebook as well a little bit.
Wonderful. Thank you again, Becky, and we will see everyone in our bonus interview. Bye.